Welcome to Sessions Online Maths Tutoring. Today we are taking a question under probability. A bag contains 4 red balls and 3 green balls. A ball is taken out at random and then put back. A second ball is then taken from the bag. What is the probability that alpha, both balls are the same color, beta, at least one of the balls is green, lambda, the balls are of different colors? Now, this is probability question with replacement. So when the first ball was taken out, it was put back, means that it was replaced before a second ball was then selected from the bag. So how do we go about this question? You can use a tree diagram to solve this particular question. So the tree diagram, the first selection, our balls are red and green. That's our first selection. Then the second selection, we can still have red and green here. Then we have red and then green. So what are our outcomes? We'll have red, red along this branch. Then we'll have red, green along this branch. Then we'll have green, red along this branch. Then we'll have green, green. So these are our 4 outcomes. So what is the probability of you selecting a red ball? How many red balls do we have? 4. Out of what's our total balls? 4 plus 3 is 7. How many green balls do we have? 3. Out of our total balls, 7. So the probability of selecting a red ball in the first selection is 4 out of 7. And then the probability of selecting a green ball in the first selection is 3 out of 7. Because these balls are replaced, the second selection will still produce the same result. So if you are looking out for the probabilities for red, red, now the first red is 4 out of 7. Now there are 2 reds. So the second red is also 4 out of 7. Red and red. When you see "and" in probability, it simply connotes multiplication. So the next red, green will also be red, 4 out of 7, times green, which is also 3 out of 7 for the second selection. Green, red, so green is 3 out of 7. And red, which is also in the second selection, as 4 out of 7. Green for the first selection is 3 out of 7. And green in the second selection is 3 out of 7. Now we can solve the questions. The probability of you selecting both balls being of the same color. Both balls being of the same color. So if both balls are of the same color, looking at our outcomes, there are 4. Which of them is the same color? Red, red, and green, green. So both being of the same color should now be red, red, which is 4 out of 7 times 4 out of 7. Or in probability connotes addition. Green, green, which is also 3 out of 7, 3 out of 7. 4 times 4 is 16, 7, 7 is 49, 3, 3 is 9, 7, 7 is 49. Same denominators, we just add our numerator. 16 plus 9, 25. We repeat one of the denominators. The second question, at least one of the balls is green. At least one of the balls is green. It means that there should be a green in it. If you want the first selection red, red, there is no green. Red, green, there is 1 green here. Green, red, there is still 1 green here. Green, green, there is also at least 1 green there. So these 3 selections would be for at least one of the balls is green. So what would that be? It can be red, green, which is 4 out of 7 times 3 out of 7. Or, this addition, it can be green, red, 3 out of 7 times 4 out of 7. Or it can be green, green, which is 3 out of 7 times 3 out of 7. So 4 times 3 is 12, 7, 7, 49. 4 times 3 is 12, 7, 7, 49. 3 times 3 is 9, 7, 7, 49. So the same denominators, so we add up our numerators. 12 plus 12, 24, plus 9, 33 out of 49. The last question is talking about the balls are of different color. The balls are of different color. If the balls are of different color, it means that red, green is one, green, red is also another. So different color, we can have red, green 4 times 4 out of 7, 3 out of 7, or, which is addition, we can have green, red 3 out of 7, 4 out of 7. So 4, 3, 12, 7, 7, 49, 3, 4, 12, 7, 7, 49. So 12 plus 12 is 24 out of 49. And this fraction cannot be reduced. And that is our answer. Thank you.